Alright, so this lesson we're going to rediscuss subsequences, arithmetic and geometric sequences, and sequences in general, but we're going to also introduce you to the concept of a series and then something called Signma notation. And we're going to be using a lot of graphing calculator today. So make sure you have one handy, and we're going to be messing around with the mode, so keep that in mind if you need it in a certain mode for another class. So we got some learning targets here, and this is a pretty quick run through of some topics that we could spend weeks on, but we just don't have the time here for introduction and pre-calc. You are going to revisit the concept of sequences and series a lot when you get to the second calculus class. So not Calc 1 that you're going to take next year, but the next one after that. So, and the concept of sequences and series, they do show up in Calc 1, but it's really heavy in Calc 2. I do remember that. A sequence is just a ordered list of numbers, so a pattern that you can see. But we have both finite and infinite sequences. And if I give you a stopping point, that means it's a finite sequence. And then pretty soon we're going to talk about something called a series, where instead of just listing the terms, then I'm going to sum them. So that's exciting. If it's a sequence, we're going to call it a sub n. That's the notation we used, and we already discussed the explicit formula for sequences, and then the recursive formula for sequences. So we already covered that in a previous lesson. Let's just kind of skip it along here in our notes. So this is a sequence. A sub n equals 1 over 2n plus 2. It is not necessarily the type of sequence we already looked at with arithmetic and geometric, and that's all right. But what I want to know is, can you find the sixth term? Well, yeah, I'm just going to plug in a 6 for n. So 1 over 2 times 6, so 1 over 12 plus 2 is, let's see, 24 twelfths, so 25 twelfths? Could have done that on my calculator, obviously, but whatever. Now this question, get my face out of the way. This question here is recursive, which means that I'm going to give you a first term starting point for your sequence, and then I'm going to give you a formula, but the formula is kind of unique. It says, take a negative of a sub n minus 1. So remember, this notation just means the previous term. And then divide that by 3. So a sub 1 is 9. I'm going to kind of list this out. A sub 2 and a sub 3, because this is the one I want, a sub 3. Alright, here we go. I'm supposed to take the opposite sign of the previous term and then divide it by 3. So the opposite sign of the previous term and divide it by 3 would be negative 3. So that is my second term, negative 3. So then for my third term, I take the opposite sign, so positive 3, of the previous term over 3, which gives me a 1. So that was super fun. All right. What we're going to do next is we're going to discover some stuff on the calculator. So there's a bunch of ways your calculator can help you find terms of a sequence. And the first two that we're going to show you, she's calling old school. Oh, Hoffbauer, you're so cute. All right. Sorry about the bells if you can hear them. All right, old school way. They want you to go to, in a TI-84 of course, they want you to go to the list key, which, second stat, right? Yep, so second stat, go over to options, and then choose sequential. Now, on my newer calculators, they're going to actually give you things to type in specifically. If you are using an older calculator, you're going to need to follow this order with the commas. Okay? So, for this example, this is what you're going to have to type in, my people with an older calculator. My people with a newer calculator, like I'm going to be using, it's going to ask you explicitly, like, what's your explicit formula and what's your variable. So don't really need to think too hard if you're using a newer calculator. It's one of the major awesome upgrades that they gave us. So, sorry, this is not the right screen. All right, so go second list. Try again. Second stat. Oh, for Pete's sake, second stat. There we go. Go over to ops and then find sequential or sequence. Face, you're in the way again. All right, enter. So I already forgot what the formula was. The explicit formula was 3n plus 2, so we'll just write 3n. Oh, pause for a moment. I had to get my pledge on. Okay, so my calculator is in, instead of function mode, it is in sequential mode. So my variable of choice is an n when I hit my variable key. If you're still in function mode, you're going to have an x. So don't worry about it. It does not matter, because we're going to now tell my calculator I'm using the variable key for my variable. It's going to start at 1, right? They want 1 to 10. I don't know where I read that. I swear I read that somewhere. Whatever. 1, it's going to start with the first term. Oh, no. Try again. First term, 1. All right. And it's going to end at the 10th term. And then you can leave step blank. It's going to know to do 1 all the time. But if you want to fill in 1, you can. On the older calculators, it doesn't ask you about how to step, so it just wants to know what we want to count by. Now for the newer calculators, it's going to paste all that information into your formula. And when you hit enter, this is what the older calculators had to type in manually. Remember, older calculators, you don't have this last one, and that's okay. Boom, there they are. So if I wanted to list out the first few terms, I'd start listing, and then I'd have to scroll over on my screen if I wanted to see the rest of them. So that's nice, right? So that's the first method. The second method is to be really old school and treat this like a function, which it is, kind of. So you'd go to your y equals, you'd program in your formula in function mode, and then you just go to your table. And you'd have your table set up to automatically fill in, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and you copy off your table. I'm not going to bother doing that because I don't want to mess with my modes right now, but it's pretty boring. I'm not saying it's wrong, it's just pretty boring. But let's look at this new one. So this one's fun. We're going to go into, there we go. We're going to go to sequence mode on our calculator. So go to your mode and please change it to sequential. So on the newer ones, you have a lot of options, and the last one should be, I think it says SEQ. So choose that one, and then go to your y equals menu. So you went to mode, make sure it's in sequential, and now we're in y equals. So there's a little cheat sheet box on your paper there. It tells you what everything represents, and a lot of these things you're not going to use. Now on my yellow calculators, I don't know if it's because of the operating system or what, there's even more options at the top where it says like a sub n plus 1, a sub n plus 2. We're always going to be highlighted on the first one, just a sub n. So don't mess with that. We'll talk later about what they're changing. And I even asked our calc teacher, like, why would I want that? And we can't come up with a reason. So just keep it how it's supposed to be in the first one, please. So this is where we're going to write our formula. So we're going to, remember, we're in sequence mode, so our variable is going to show up as an n. And I forgot what our formula was. It was something, right? 3n plus 2. So that is the sequence formula, the explicit formula. And then the minimum is the starting term. So I think they want 1. And that's all you need to do. So now what I'm going to have you do is go to the table, right? We're going to go to the table here. Is that what they want us to look at? Cool. And then if you want to see the graph, you sure can. But for now, let's go to our table. And notice there's errors because our sequence was not defined properly there. But here's our sequence starting. So it goes, the first term is 1, second term is 8, third term is 11, and so on and so on and so on. So if they wanted us to find some obscure term, like the 105th term, I wouldn't scroll down to 105. I would just go to my table set, and I would put the independent into ask mode, and then I would manually type in 105, because who wants to scroll that far? So anywho, there's your sequence. That's pretty exciting, right? No, it's not. If you want to look at the graph, you can. I don't know. You want to look at the graph? Knowing your class, the answer is going to be no, so I'm just going to skip it. All right. So here, they want us to find the 8th term. It's up to you how you find it, guys. They're suggesting that maybe you use your calculator. Now that first one is an explicit formula, so I don't really know if it's smarter to use my calculators like sequence mode. It's pretty boring, so I would just type in 8 for the term. So 8 to the 3rd power minus 1 over 2. And the 8th term is 255.5. Sure could have got that on sequence mode on your table, but why bother? Now this one I would like to use my calculator for. This is recursive. So right here, remember a sub n minus 1? is that previous term business. So here's what we're going to do. We're going to type this info into our calculator. This one's a little more complicated to do, but we'll get around it. All right, so we're going to start with our first term. That's not going to change here, but our formula is 2 times, now this is kind of confusing. It's, how do I want to say this? All right, so see how it says like u of n here? So they're using u instead of a, which is really confusing, right? So we use a sub n minus 1. The calculator uses u sub n minus 1. I don't really know why. It's probably an American thing that we use a. I have no idea. A for America. I'm just making that up. But the u is like literally the letter u right above 7 here. So second u. And then they don't do subscripts, so what you're going to have to do is just put parentheses and then say n minus 1. So that's how we type recursion into our calculator. U n, oops, too many, delete. U parenthesis n minus 1 means a sub n minus 1. Anywho, I think I lost half my formula here. Isn't it plus 5 at the end? Okay, there we go. And then remember, the first term, that is given to us, right? It's 7. There we go. I'm going to delete that. Delete. Let's see if I could screw this up anymore. I don't know. All right, we want the 9th term, so I don't have a problem just scrolling down to the 9th term. Let's find out what we have. I regret doing this now. I forgot I have a lag. Stop. Okay. All right, I screwed something up. Let's see if I can figure out what I screwed up. I'm going to pause for a moment. So I figured out what I screwed up. I can't read. It's not the 9th term. I want the 4th term. Oh, I'm done. Alright, so the 4th term is 91. I didn't screw up. That's very exciting. Alright, so a little recap here, guys. This is how you type recursion in. The minimum value is going to be the given starting value. They have to give you that for recursive, remember? Be careful how you type that, though. That's all I would caution. So, I like using the sequence mode for recursive formulas. I think that's awesome. Oh, it does warn you. Sometimes they decide to start sequences with the 0th term. So you'll have to keep that in mind. Instead of plugging in n equals 1, you're going to start with n equals 0, and it really messes everything up. So just a fair warning that sometimes they do this. So these are some vocab words for you, and this comes up in calc quite a bit, in calc 1. Your series or sequence can converge or diverge, and if it goes towards a specific value, an outcome, it's convergent. So this is known as a limit in calculus. And when you look at the graph, it's really easy to see. When you look at table of values, it's okay to see it that way. Divergent, though, is really clear. Like, they're going to start going off in all different directions. So when you plug in the, when you find the 8th term of the sequence, it gives you one value. When you find the 9th term, it gives you a totally different value. And maybe it even toggles and does really weird stuff. So oftentimes, you'll see them diverge off to an infinity or a negative infinity. And that means that the limit does not exist. Every time I say that, I think about the Mean Girls movie. The limit does not exist. Okay, so convergent or divergent is easiest seen when looking at a graph. I will warn you. So this example here is not in your notes, I don't think. Oh yeah, it is in your notes. But notice how it just keeps going down, 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 down. This is a divergent sequence. It's not approaching any particular value, so we're looking basically for an asymptote, if you want to bring back an old word. This one is converging to what looks like an asymptote, though. So you notice right here, I was going to point at my screen like you could see that, converging right here down to the x-axis to 0. So this one is converging towards 0. The limit is approaching 0, if you want to say it that way. And this one's unusual because every time you go toggle between the values, it's like output of positive 0.25, negative 0.25, and it keeps toggling between them. Well, those are not the same values, so it's not approaching the same value, which means it is not approaching a limit. So it is divergent. A lot of kids like to argue with that one because they're like, oh, but it's practically the same. No, actually it's completely opposite. Positive 1/4 and negative 1/4. So these examples here, convergent. If you were to graph this, it's basically, well, I think it basically looks like this when you graph it. So it approaches some sort of an asymptote. This one here, let's see. I don't have these graphed. Womp womp. We could graph them. You know what? I'm going to get this programmed in my calculator. I'm going to show you the graph on there. That'll be the best way because, you know, I can't graph. So hold on a moment. This is not convergent. So the more I thought about it, I was like, that was dumb. Guys, it looks like that. And my graphing calculator isn't graphing like forever. It's just going to like 10 or something. But it's not going to converge to anything. And if you think about that mathematically, it's just going to keep adding 4, adding 4, adding 4. So it's approaching infinity. I don't know what we're thinking there. Sorry, my bad. And then this guy, negative 1 to the nth power. Let's see. This should be, well, time out again. Let me get the graph. So I have a stupid window here, but see these blue dots? And this is one of those ones where it toggles between positive and negative values of 3, like positive 3, negative 3, positive 3, negative 3. So this is why this one should be divergent. There we go. What happened there? All right. No idea what's going on. Anywho, this one, first you have to figure out the pattern and see what they're trying to have you do. So it looks to me like here we subtracted 2, and here we subtracted 4. So here we must be subtracting 6. So then we're going to subtract 8 and subtract 10. And it's just going to keep going down, 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 more to negative infinity. So it's not going to approach any sort of limit. So this is divergent. Spelled it right this time. Cool. This one is a little interesting because that negative 1 to the nth power makes it kind of oscillate between positive and negative. But if you, this is kind of annoying. You know what we're going to do? We're going to graph this. Pause. I'm going to graph it. I'm going to show you what the graph looks like. And again, it's not graphing this infinitely, but you can see the values are coming, they're coming down, positive, negative, but they're kind of toggling over the x-axis here, right? So they're approaching a value of 0. They're getting really, really close. So it's going to be teeny tiny numbers on each side of the axes. So this is converging to a value of 0. Convergent. All right. So series. Series is what happens when you take your sequence and then you decide to add it all up. So they're going to notate series in your book by an S sub n instead of a sub n. That's how you know the difference. They'll also usually say in the directions, like find the sum of the series or something like that, or find the sum of the infinite sequence or finite sequence series, excuse me. Finite meaning it ends, infinite does not. Now if it's an infinite series and you're supposed to add up a bunch of numbers, they should be adding up to a number, like approaching a number, which means they should be converging down to like 0 or something. So you'll do lots and lots of these in calculus. But for us, we're going to be finding partial sums mostly here on our calculator using some neat little sequence features. We're also going to talk about Signma notation shortly. They want you to find the fourth partial sum. So they give you a sequence first, a sub n, and then they want you to find all the values of the first, second, third, and fourth term. So here they are. And here, and here, and here. And then they want you to add them up. So that's not too hard, right? You can add numbers. Well, it gets a little more complicated when the functions become more complicated or you have more terms. So you can do this old school. You can find the first whatever terms and then add them up. We're going to be using our calculator mostly. So infinite series, or sequence, excuse me, is a listing of numbers that doesn't stop. Infinite series is an addition of those numbers. It never stops though. So you can imagine this one is going to go off to infinity. So it's going to, the sum is going to approach infinity as well. Those are actually really easy. But if you have partial sums, this is the sequence, but then you can actually go back and series them by adding them together. So keep that in mind. The notation is a little tricky and weird. This notation, however, this is called a sigma. It's a capital Greek letter sigma. And it's going to start with your letter N starting somewhere. Usually it's 1, so this is the start. And then whatever number is up here is the end. So they define it generally as k, but that's for infinite, or a general term. Usually they'll give you like a 4, which means you go from the first term to the fourth term. And then you add them all up until you get to the kth term. Sound like I have a weird list. Kth term. All right. So the notation here is crazy, right? Sum of these guys, find the 7th partial sum. So I don't have an actual function, but I mean, there's a few ways we could do this. We could just continue the pattern out to the 7th one. So you got 1, 2, 3, 4, we need 3 more. 5, 6, 7. All right, here we go. Here's the rule. If you want to use Sigma notation and program your calculator to do something, you need a formula. If you don't have a formula, you'd have to find a formula. So sometimes, in this case, it's just easier to manually do it. So let's figure out the pattern here, guys. You are, let's see, here we added 12, right? Did I get that right? Yeah. And then here, it looks like they added 11, so I think I see the pattern. Here they added 10. So the next one, they're going to add 9, so they bring you to a 20. And then they're going to add 8, so that's a 28. And they're going to add 7, so that's a 35. So then all I'm going to do is take these numbers and add them up. Which, through the magic of me already keying this, I already have the answer, I think. Or not. I never added it. Alright, negative 22 plus negative 10 plus 1 plus 11 plus 20 plus 28 plus 35. Okay, I got 63, but you know I can't type, so if you got something else, I apologize. So that wasn't too bad. Now, if I have a formula, interpreting the notation is important for us. So when they have this written down for us, they want us to add up the 1st through the 5th term. So it kind of got cut off here, but here's the 1st, 2nd, 3rd, 4th, 5th term, and they added all of them together. That's what that sigma means, to sum them together, and they got a 45. So I'm going to be doing a lot of these on my calculator, because I hate doing these by hand. So again, here, totally could do these by hand, because you're going to sense a pattern. This one goes to infinity. You're like, Abruzzo, how am I going to add to infinity? Well, look what happens. The larger your denominator becomes, what happens to your number? It starts getting teeny, 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 tiny. So after you add like these first few together, after a while, those little decimals become negligible, and you see a pattern forming, basically. So it's going to be 0.7 repeating, which converges to the number 7/9. That's the kind of fun stuff you get to do in calculus, though. All right, so this guy, we're going to be using our graphing calculator to do this. There would be no problem with you doing these by hand, though. So if you want to be old school and do this by hand, you sure can. 2 to the nth power over 4. So you're going to have to find your 1st, 2nd, 3rd, and 4th term, and then you're going to have to add them together. Totally could, right? And that would not be very difficult. But let me show you a way you can do this on your calculator. We're going to go, not here, we are going to go to 2 places on the same button, okay? Yeah. So go to the list key again. Let me get that out of there first. And then in, let's see, I always forget this one. I think it's in math. Go over to math. Yeah. And you have a command that's called sum. It's going to add together whatever you put in after this. So choose sum, which is what the series means. And then we want to sequence some stuff. So while in the sum command, now go back to the list menu. This time go to options and go to sequence. So we're going to sum a sequence. All right, put your formula in, which is 2 to the nth power over 4. Now, I can already hear you guys going, Abruzzo, I could have already had this done. You're very slow. I know, but I like using my calculator, so get over it. 2 to the nth power over 4. Wah, wah, wah. Now they want me to start at 1, the first term, and they wanted me to end it at 4. So make sure you end it at 4. And we're counting by ones always, so that's not exciting. Just skip over that. My people who are doing this old school, you're going to type 2 to the nth power over 4, comma n, comma 1, comma 4, and then you're going to end your parenthesis here. And then, blam, the answer is 7.5. So that was nice. I thought it was nice, but whatever. So if you really love to do that one by hand and just add up the 4 terms, I'm not going to stop you. The answer is 7.5 regardless of how you do this. So here, the 6th partial sum of the sequence. So if you want to use the sigma notation, basically what you're doing is you're starting at 1 and you're going up to the 6th term and you're using the formula for n minus 1. So again, I'm going to use my calculator because I like it. So I'm going back, and sometimes you can overtype this and change it, but I don't know if it's worth it, guys. So go to list, pull up the sum, and then while still in that command, go back to list and pull up sequence. All right, what's my new sequence here? 4n minus 1. Let's clear this out. Overtype is really annoying in that menu, so I suggest you just get rid of it all the time. 4n minus 1, and then we want to go to the 6th term, right? 1 to 6. Magic is about to happen. Ready? If you're using an old school calculator, you type this in and you stop right here. Kablam! The answer's 78. Nice. Alright. It's more of the same, guys. I think I'm going to stop those examples. They're not real tricky, are they? Thank you, calculator. If you're doing these on your own, by the way, I'll jot down what the answers should come out to, just so you know. So this one, I already forgot what it was. It was 78, wasn't it? All right. And this one, if you do this on your calculator, n squared minus 2, make sure you have that typed in right. Now be careful, this is the 3rd term to the 7th term. So make sure you're starting at 3 and ending at 7. It comes out to 125. And this one, careful typing that one please, comes out to 11.8125. But if you hit math enter enter, just like always, it'll bring it back to a fraction, 189 over 16. So, yay calculator, you win the prize today for being awesome. Alright, this is number 9 now, and it's a vacuum pump removes 15% of the air from the inflated mattress, and the air mattress currently contains 20 liters of air before the pump starts. Now this is weird. We're going to start our listing, instead of at 1, we're going to have to start it at 0, so we'll talk about that. Write the first 3 terms of the sequence representing the amount of air. Alright, so if you're removing 15%, that means you're keeping 85%. So the first time it removes air, if you multiply that by 85%, I think I wrote this down somewhere, you get 17. But we got to be careful here. The first 4 terms, we actually have to call the first one the 0th term. So before anything happened, we had 20 liters. And then after the amount of air that remains after the first stroke of the piston, it's now got 17 in it. And then the second stroke of the piston, so we're going to multiply this guy by 0.85. I got 14.45. And then after the third stroke of the piston, oh, they don't want any more. They wanted 3 terms. So there you go. So that was weird. They defined the sequence to start at, like, before the piston even made of those things. So you have to be careful with the context of your application questions and how you're defining your sequence. So now they want an explicit and a recursive formula. How fun is this? Okay. So this is a common ratio problem, so it's a geometric. So what I'm going to write down is the easiest one for me to remember, which is the original amount. Now this is a little confusing. So times the ratio, 0.85. And then for the power, usually it's to the n minus 1 power. So, sorry, I was talking to somebody. If we keep this as the nth power, and then we define our sequence to start at n equals 0, like we did before, because that would be 0 pumps of the piston. So that would work. There's like a bunch of other ones. If you wanted to do n minus 1 power, you could, except it wouldn't be n minus 1, you have to do n plus 1, right? So that's confusing. Let's not do that. Let's talk about recursive though. So recursive would be if you take your previous term and you multiply it by 0.85, but your 0th term, that's confusing, right? Because it's 0 piston pumps, starts off with 20. So that's confusing. At some point for your reader, whoever's interpreting this, you'd have to define that n represents the number of piston pumps that have gone through. And then to figure out whether it converges or diverges, if you looked at the graph, it does converge to 0. It approaches 0, which makes sense. Like, it's how much air is left in the air mattress. Well, at some point, there's going to be little to no air in the air mattress, so that makes a lot of sense. All right, there's your brief introduction to arithmetic and geometric sequences and series now, and using a lot of graphing calculator.